Hi everyone. We're continuing in the quadratic chapter unit. We've learned lots of skills. We've been factoring, we've learned about imaginary and complex numbers. We've been looking at parabolas and the graphs and using graphing techniques and regressions. And today we're going to start with another skill, and it's called completing the square. And we use this to find the zeros of a quadratic if factoring doesn't work, because factoring isn't always going to work. Some things are not factorable. So we're going to solve some equations by using the square root property, and we're going to also learn to complete the square. Okay, remember that when we have a quadratic always yields two solutions, two roots, two intercepts, or at least a double root. Sometimes they are real solutions, sometimes they are not. So here we're going to use the square root property to solve for the two values that make this true. So one way to do this would be to factor. Another way would be just to solve for x. So I'm going to add 25 to the other side. Okay, and that leaves me x squared is equal to 25. I'm going to take the square root of both sides, which is going to yield me two answers, positive and negative, and the square root of 25 is 5. So these would be two solutions. In other words, it would be a parabola that looks like this, that crosses at 5 and negative 5. Those are my two solutions. Okay, you can do the same thing over here with this one. This is already I've got one on one side, so I'm going to take the square root of both sides. And I have, remember, if you take the square root of something squared, you just have what's left inside the parentheses, equals, don't forget the plus or minus, and the square root of 36 is 6. Okay, I'm not quite done because I'm going to subtract 1 to both sides. And I have x is equal to negative 1 plus or minus 6. Right, so that yields me two answers, negative 1 plus 6, which is 5, and negative 1 minus 6, which is negative 7. And these are my two answers. Okay, so I'm going to solve this equation by using the square root property, and I'm going to add another step. So the first thing I want to do is I want to factor this. And I look, and x squared is a perfect square, and 49 is a perfect square. So this is actually going to factor nicely into a perfect square. Okay, so I'm going to have x and x. The square root of 49 is 7, and there's a plus, right? So remember that you can write that, since it's the same factor, I can write it twice, and this looks like the second problem on the previous screen. So I can use the square root property to solve, and I'm going to take the square root of both sides. So on this side I'll have x plus 7 is equal to plus or minus, don't forget, the square root of 64 is 8. I'm going to subtract the 7 to the other side, and x is going to equal negative 7 plus or minus 8, negative 7 plus 8, and negative 7 minus 8. So 1 and negative 15 are my roots. Those are my solutions. Okay, completing the square says, we're going to start stair-step this. So find the value of c that makes x squared plus bx plus c a perfect square. Then write the trinomial as a perfect square. Okay, so I'm going to start with this one over here, x squared plus 6x plus c. Right, so what we want to know is this number c has to be a perfect square. Okay, so for instance, I'm going to start up here. So if I have x plus 2 quantity squared, we talked about this, right? We would square this one, and we would square this one, right? 2 squared. And then you would take 2 times x and double it. 4x plus 4 doubles it, all right? So if you'll notice here that taking half of this number and squaring it will get me this number, right? So if I took half of this number, which is 3, and squared it, this number here would be a 9. So let's see if that works. Plus 6x plus 9. Well, 9 is a perfect square. So if I were going to factor this, I would have x plus 3 squared. So there's a relationship between these numbers. And I guess what I'm trying to tell you is this b number right here, remember a, b, and c, this b number, if I take half of it and square it, I'm going to get c. So if you take the b number, take half of it, and square it, that's going to equal c in a perfect square every time. All right, so I'm looking here. A is 1, B is 1, C is, we don't know. We need to find C. So if we take B, which is 1, and take half of it, right, and then square it, that's going to equal 1 squared over 2 squared, which is 1/4. C is going to be 1/4. So you can begin here to see a pattern. You see that the B number divided by 2, right, and squared is going to equal C. And then when you go to factor it, you're going to have x plus b over 2, quantity squared. And it's plus because that's plus. If it were minus, it would be that. So once again, here are the steps to completing the square. Okay, because that's what you're trying to do, is we're trying to factor it or turn it into a perfect square so that we can solve it by using the square root property. So here are the steps, right? If you have x squared plus bx and you need to know what c is, right? This is c. Then you take half of b, right? And then square it. So this will be half of b and then square it. And that's what that will equal. And that will equal c. So we're going to find 1/2 of b. That's our step. We're going to square it. We're going to add it. And then we're going to factor. So please be sure that you have this, all of this, in your notes, because that's what we're fixing to do. Okay, so here we are. We're going to put all these steps together, and we're going to solve an equation by completing the square. All right, so I have x squared plus 4x plus 12. And so what I'm going to do, first of all, is I'm going to take the c that's already here, and I'm going to move it to the other side by adding 12. So I have x squared plus 4x, because 12 is not a perfect square. Agreed? It's not a perfect square. All right, so I'm going to take, now I'm going to turn this side into a perfect square. So I'm going to do x squared plus 4x, right? I'm going to take half of 4, which is 2, and square it and add it to this side. Well, if I add 4 to one side, I've got to add 4 to the other side to keep it even. Okay, now I'm going to factor this. It's a perfect square. So it's x plus, because that's plus. The first one is plus. And then what was half of 4? 2 equals 16. All right, so now that I've done this, I can take the square root of both sides, and I have x plus 2 is equal to plus or minus the square root of 16, which is 4. X equals negative 2 plus or minus 4. So I'm going to have negative 2 plus 4, which is 2, negative 2 minus 4, which is negative 6, and those are my answers. Now, if I get whole numbers for answers, positive or negative, doesn't matter, it meant that the original thing could factor. That's probably what I would do first, is try to see if it'll factor. Completing the square always works, whether you can factor it or not, whether you can use the quadratic formula or not. Completing the square always works. Factoring doesn't always work. But completing the square will always work. And graphing won't always work, because sometimes you have complex numbers, which you don't mind on here. You'll get complex numbers, but it'll still be fine. Okay, let's do another example of completing the square. All right. So the first thing that I want to do is I want to subtract the 11. The first c, because 11 is not a perfect square. So when I move that to the other side, I have x squared minus 8x. I'm going to leave a little bit of room. And 1 minus 11 is negative 10. Okay, so now I'm going to complete the square. So first thing you want to do is you want to move the C to the other side. Okay, all right, then here what I want to do is I want to go ahead and complete the square and factor. So I'm going to go ahead and write this to save me a little bit of time. But I'm going to have x minus, I know that. What's half of 8? Half of 8 is 4. 4 squared is 16. So I'm going to add the 16 to this side over here as well. And I'm going to have x minus 4 quantity squared equals 6. All right, it's time to take the square root of both sides to get my two answers. So I have x minus 4 equals plus or minus the square root of 6. Okay, then I'm going to add the 4 to the other side, and my x is going to equal 4 plus or minus the square root of 6. These are not whole numbers. That means that the original did not factor. So you can actually just leave your answers just like that, or you can work out the decimals on a calculator, but this is sufficient. Okay. Okay, so if you have one of these that doesn't have, that a is not equal to 1, the first coefficient is not equal to 1, then you actually have to add another step here. So I'm going to demonstrate what that looks like, and then we'll work a bunch of these in class. Okay, so the first thing you're going to do is just like you've been doing before, is you're going to subtract 5 to the other side. Okay, and then I have 2x squared plus 4x is equal to negative 5. Okay, then the next thing you need to do is you need to factor out a from this side of the equation. So I'm going to factor out the common factor, which is 2, plus, but it doesn't have to be a common factor. All right, and that equals negative 5. So now, from now on, you're going to have that 2 in a problem, right? So I'm going to go ahead and factor it. So this is going to be x plus, take half of 2, which is 1, right? 1 squared is 1. So I'm adding a 1 here. Now, I'm not going to add 1 over here. Notice that since I factored out the 2, that's actually 2. So over here I'm going to have negative 3. Okay, so before I use the square root property, I'm going to divide both sides by 2, right? I'm going to have a negative number, so this is going to be interesting. And I'm left with x plus 1 quantity squared is equal to negative 3 over 2. All right, so we're now to the part that we've got something to the power to squared and then equal to a value, and so I'm going to take the square root of both sides to get my two answers. So I'm left with x plus 1 is equal to, don't forget, plus or minus the square root of negative 3 over 2, right? And then I subtract the 1. So x is equal to negative 1 plus or minus the square root of negative 3 over 2. All right, so let's work with that for just one little second, right? I can rewrite that as the square root of negative 3 over the square root of 2. Well, the square root of negative 3 is I square root of 3 over the square root of 2. Okay, so my final answer, and it says to rationalize. I know you should rationalize it, but it really doesn't matter because the answer that you get is not real, and you can obtain a decimal for these if you just throw it in the calculator. So this is your final answer, right? So these are not real. So completing the square is going to find all the roots, whether they're real, whether they're not real, whether they're irrational, they have a square root in them, or if they're whole numbers. So you can always use completing the square. It's a great skill to have, and easier to do, I think, if you can remember the order, than the quadratic formula. So we're going to do more of these in class, but be sure you took good notes. You might want to watch this again sometime and just see if you can get the steps down. Work the problem ahead of me and then stop the video. So I'll see you in class.